we're diving into a story about making the invisible visible with a kind of clarity we've never had before. It's all about how a powerful scientific tool is getting a massive upgrade thanks to a new set of AI-powered eyes.
So let's start with the central challenge. How in the world do you track one single particle while it's zipping around inside something you can't see into? We're talking about a running engine or a complex chemical reactor. It sounds impossible, but for scientists and engineers, answering this is absolutely critical.
The answer lies in a pretty remarkable technology called PEPT. PEPT stands for Positron Emission Particle Tracking, and it works like a tiny little GPS for that single particle. Scientists tag a particle with a substance that emits positrons, the antimatter version of electrons. When a positron meets an electron, they annihilate each other and shoot out gamma rays, and those rays can be detected outside the machine. This allows us to follow its exact path, even deep inside a totally solid opaque system. Why does this matter? Because this technology reveals the hidden dynamics inside all sorts of critical equipment. We can suddenly see how lubricants are actually flowing in an engine, how chemicals are mixing inside a reactor, or how powders are blending in a pharmaceutical process. It gives us a window into these secret worlds. But even this powerful technology isn't perfect. It faces a pretty big challenge that seriously limits its vision. The fundamental problem is noise. The raw data you get, it's messy. The best way to picture it is trying to take a crystal clear photo of a single, tiny bird in the middle of a raging blizzard. The real signal gets completely buried in a storm of false information.
So what causes this data blizzard? A few culprits. Signals can bounce around incorrectly, creating scatter events. Sometimes random signals just happen to align to create a false positive, a random coincidence. And on top of that, the detectors themselves sometimes just don't capture all the information. All of this corrupts the data and blurs the particle's true path.
To cut through that blizzard, scientists are now using an incredibly powerful new tool, artificial intelligence. Scientists first build a perfect virtual world. They train the AI in the simulated environment where every answer is already known, and then they apply that expert model to the chaotic data from the real world. This enhancement process unfolds in 4 key steps. First, they simulate. Using what are called Monte Carlo simulations, they generate millions of flawless particle events. This creates the perfect training ground. Second, they train. The AI studies this perfect data to learn how to distinguish a true signal from all the noise. Third, they apply this trained model to the real messy PEPT data. And finally, they fine-tune it with a small amount of real data, just to bridge any tiny gaps between the simulation and reality. Let's break down the AI's 3-pronged attack on this noise. Its first job is to act as an intelligent filter. For every single signal the detector picks up, it calculates the probability of it being true. Is this the real particle, or just a random coincidence, or a scatter event? The AI learns to spot and just throw out the fakes. But it doesn't just filter signals. Its second job is to boost precision. The AI pinpoints the most likely location of the event along its path. And in a really clever twist, it can even take lower quality data and digitally enhance it, making it look as if it came from a much more advanced, high-resolution scanner. The AI's third function is to clean house. It's trained to estimate the amount of background scatter, and then digitally subtract it. It cleans the data before the main analysis even starts, resulting in a much clearer signal to work with. The crucial point here is the transformation. Before the AI, you have noisy, scattered data, which leads to lower resolution and really just an estimated position. After the AI does its work, you get a clean, filtered signal with high precision and a pinpointed location. So what does all this cleanup and precision actually achieve? With this AI-driven method, researchers can now pinpoint a particle's location with an error margin of less than a single millimeter. It's a key that unlocks new doors. This massive leap in precision will allow for brand new discoveries in physics, more efficient engineering designs, and even advances in medicine, where similar tracking technologies are used. We get a fundamentally clearer picture of how the world works on a very small scale. AI can provide a crystal clear view into a world that was once a complete blur. What other invisible worlds and hidden processes are out there right now, just waiting to be explored with this newfound clarity?